How to create and publish IIIF Manifests using the Fedora Repository and SPARQL. The starting point is the Fedora Repository version 4 with two existing collections, Test and Edition. I'll be creating a new collection called SWIB16 with an object ID 0098 in the next steps. I've extended the Library of Congress Beggar Spring Rich client application with a Fedora Java client to make an implementation tool called the Modeler that features prominently in the creation of the data model. There are many benefits to the bagging paradigm for file and metadata packaging, though this is another topic entirely. It's sufficient to note for this presentation that the file set for the 0098 object has been saved already as a bag, and I will simply load this bag into the modeler as a starting point. The files must be ordered with a numerical sequence in accordance with our expected presentation sequence. The baginfo.txt contains key value pairs that comprise the primary variables in the data model that are the collection ID, the object ID, the service host names, and the containers. These variables can be changed in this form. The flexibility of this metadata packaging approach is a significant advantage for deployment to multiple instances, for example, local dev, remote testing, remote production. All that is required to redeploy is to change the host names. It is possible to add optional metadata labels like title, author, attribution, etc. here as well. Also, you may note that the text HOCR resource field that can be used as a source for the creation of text model that allows full text searching and annotation display in the images. The modeling process is a controlled sequence that starts with creating containers. This is a put request that happens instantly using the Fedora REST API. Switching back to the Fedora interface, refreshing the page reveals the newly created collection SWIB16, its child resource 0098, and its children, which are the default containers to the IIIF model. The next step is to upload the binaries to the resource container. Using the serialization extension to Fedora, these binaries are subsequently serialized to the file system where they are ingested by the image server. This group of 28 files is 751 megabytes, and putting them into Fedora is quite fast, even over the wire to a remote instance. Here it takes about 15 seconds to finish. After the images are uploaded, then the image metadata needs to be patched. This is a practical benefit of using Fedora because the binary metadata descriptions are essentially attached as a child object called FCR metadata, so it can be independently referenced. For the IIIF manifest, the image dimensions are required as well as the service URI to the image server instance. Annotation lists are created next. The lists are required before the canvases. The canvases are then created. Patching the canvases depends on the resources and lists existing first. Switching back to the Fedora interface, dereferencing a canvas URI shows the metadata that was just patched, which includes the width and height and its associated image annotation and its label, which matches the label and sequence of the image itself. Now here's where it gets interesting, the sequences. Most manifests will only have one sequence, and this model makes the assumption that it has the identifier normal. This is probably the most important step in the whole process, patching the sequence. This creates a semantic glue that connects the canvas and image resources together as an RDF list. In the Fedora interface, we can see how the RDF list is represented with the RDF first and RDF rest properties. The first RDF first is called the head, must be a resource node and not blank. And the last node in the list, called the tail, must use the RDF nil property. After the sequence has been created, then the manifest can be patched. Manifests have many optional properties, but they must have at least one SC has sequences. The last step that is required for a normal image manifest in this system is the creation of XML files that are used by the image service for identifiers. These XML files are serialized into the same directory as the image binaries where they are post-processed by the image server ingester. Now we can use the manifest service to get the JSON LD representation of all of this linked data that we just created that has now been indexed into the Triple Store. The manifest service is an API interface directly to SPARQL. This service expects the IRI template node parameter and then gets the manifest graph from the Triple Store as n triples, and then uses the JSON LD processing library from RDF and framing methods to convert the graph and make it look beautiful. like this. This is the expected serialization format for a IIIF manifest and can be used without modification by a client like the Universal Viewer. The manifest URI can also be dereferenced back to the Fedora container so that supplementary data, if available, can be implemented by a client. Moving on to the next process, creating the text model. This is optional, but I think that it's pretty cool and worth demonstrating. All the following steps read the HOCR document and create nodes and values based entirely on that document. The first step is to create the pages. Second step, create the areas. Third step, create the lines. Here I pause the recording and check the status of the indexing and serialization in the hot.io console log. The creation of thousands of new triples does not happen instantaneously, so indexing the words may take hours depending on how large of a document is being processed. Apache Camel is quite robust, however, and can still handle routing large message queues. During the pause, I have also started the Universal Viewer instance so that we can view the newly created manifest. This is the Universal Viewer. I'm just showing here that the manifest URI loaded into the viewer points back to the manifest that we just created. You may notice that when the images load, the tiles have not yet been cached, so this is the first time they have been loaded from the image server. Subsequent loads will appear much faster. Everything appears to work, so we've created and published the IIIF book representation in less than 10 minutes. Returning back to the text model creation, the next step is to patch the pages, areas, lines, and words. This basically means to create the RDF lists that create the sequences that connect them together. It is possible that some pages may be blank. In this case, page 18 has no areas, so the client simply reports that a patch request for that page cannot be done and moves on. Another benefit of the REST interface of Fedora. The same patching process is repeated for areas and lines and words. Switching back to the Fedora interface, we can see how a Word resource looks. It has a content characters property that contains the literal value of its text. It also has the OA has target property, which is the pointer to the geometric location on the image. The final step in the process is patching the annotation lists. This builds pages of Word annotations and assigns them to their list containers that were created earlier. In order for a client like Mirador to get these annotations for a particular page, in this model, a service URI is used that executes an annotation list query that uses the list node resource rather than dereferencing the list node itself. In the process of generating the annotation list, all the words for that page have to be retrieved from the Fedora repository. If we check the list here, you can see that it's made again of the RDF first and RDF rest properties, where each one of the blank nodes contains a word resource. Switching back to hot IO now, we can check the indexing process, which takes some time. Looking inside the manifest service now, I demonstrate here how the example manifest SPARQL query looks like when executed directly from the endpoint. Note that it is a construct type query. The where part of the query uses property paths to traverse the RDF list. It's a rather complex query actually, but it works. Here I demonstrate that while it is possible to serialize JSON LD directly from SPARQL, this looks nothing like the JSON LD format that is expected by the IIIF presentation API. There are several important technical differences. The big issue is with the @graph keyword. This is not accepted by the IIIF client. The second is that from RDF does not know how to read a Scala MyRI and expects a list to be constructed with blank nodes, so it cannot format the RDF list as arrays. I wrote a method that incorporated it into the from RDF API that takes Scala MyRIs and changes them into blank nodes so that the service can convert the RDF list as arrays. The third is that JSON LD has a variety of shapes, namely expanded, compacted, flattened, and framed. The IIIF format is framed. The manifest service is able to take the from RDF result JSON LD and then frame it with a nested callback from the same request. This is the ntriples format that the from RDF method expects and what is delivered to the manifest service. Switching back to the manifest service IIIF serialization of the same data, it is pretty clear to me why the JSON LD is so nice. A human can actually read it. Now I demonstrate how the text model is used by the client. Universal Viewer Search Within feature accesses the search service API that is specified in the manifest. My implementation does this with SPARQL, but others may use Solr. Either way, it is just a Q equals keyword search. The query results are returned as an annotation set from the manifest service, not a list, and the client reads the target values of the results and then it highlights them on the canvases. Here I show the raw results of the query that was just executed from the client. The client expects this exact format for the results. Another benefit of using Fedora resource identifiers rather than hash type URIs is that they can be dereferenced. I now switch to the Mirador viewer to demonstrate how an annotation list can be rendered. This functionality is not yet supported by the Universal Viewer. Going back to the page 12 and the keyword Dixie that we just located, if I toggle the annotations view using the button in the upper left-hand corner, then all the content characters that have been assigned the OA linking property will be rendered on the image. While a label pop-up seems simple, it is possible to extend the annotation display to include any properties for that word resource. Here I switch back to the manifest and show the raw value of the annotation list that was just used by Mirador. And voila, there is Dixie as a word resource 12174 in the annotation list. In my view, specific and concrete client implementations have vast possibilities when backed by a flexible and linked open data model like the one that I've just presented. Thank you. I'm sure there are questions, so I'll leave the remaining time for discussion.